All right, good day everyone, and welcome to this lesson on calculus. Now, speaking of calculus, we are going to be dealing with about four different topics on calculus. The first is relations and functions, the second is conic sections, and the third is differentiation, and then the fourth is integration. Now, in relations and functions, we'll be looking at the relationship between one set and another, the types of relations, and as well the types of functions also. And under conic sections, we'll be considering um, the different segments of cones, different parts in which cones can be divided. And then under differentiation, we're looking at different techniques of differentiation and as well also in integration. So we are going to begin with the first, which is relations and functions. We begin with the first, which is relations and functions. And so when we speak of relation, we say that relation is a way of relating the members of a particular set to another set, to members of another set. So you are actually checking the members in one set and relating it to another set. So we can say a relation is a way of establishing a bond between the elements of two or more sets, or between elements in the same set. So when we speak of relations, we are talking about establishing a bond, that is, members of a particular set, for example, members of a family or of a particular family, how those members are actually related to members of probably another family or a small family. So elements of a set can be related to elements of another set. So for example, if we have set A, and let's assume set A is made up of 1, 2, and 3, and set B is made up of also, let's say, 4, 5, 6. If we say that the members of family A are related to the members of family B, so basically we just simply use an arrow to indicate the relationship. We use an arrow to indicate the relationship. So we are saying that members of family A or set A are related to members of set B. So if the members in set A is 1, 2, and 3, we can say that the members of set B is 4, 5, 6. So then this is what we'll be considering in relations, how to establish relationship between one set, members of one set, and another. And then again, we are using an arrow to indicate. The arrows can go other way around because of, we are saying that every member in set A is related to every member in set B. And we are actually making use of a two-side arrow, as is a line with two heads on both sides. So indicating that while A is related to B, B is also related to A. Now, let's consider an example. Let's consider an example. For instance, we can say, let's consider the following statement. We consider the statement that says 4 is greater than 1, 4 is greater than 3 and 3 is greater than 1. Now we have three statements and we can represent it using this. We can say this is 4 represented by an arrow to 1, and then this is 3 represented by an arrow also to 1, because the statement says that 4 is greater than 1. So we are linking 4 to 1, showing the relationship between 4 and 1. And then we also said that 3 is greater than 1. So we are showing also the relationship between 3 and 1. And then 4 being greater than 3 will also show the relationship between 4 and 3. So this is just an example showing relationship. Another example is, let's look at or check the multiples of 6. Multiples of 6 in a set A. Now we have something like this, and we have 6 here, and so we are having 6, 8, 9, 12, 15, and 18. We're having 6, 8, 9, 12, 15, and 18. So this set, we call it the set A according to the question. Now, the question is asking us to look for multiples of 6 from these members of this set. So we can easily identify the multiples of 6. So that will be to 6. The next multiple of 6 will be 12. The next multiple of 6 will be 18. So these are just examples to illustrate how we can show the relationship between members of a particular set or members of different sets. So now let's look at when we are talking about relations and functions, there are things we have to consider. And one of those things is what we call domain, and the second one is what we call range. The first one is what we call domain, and the second is what we call range. So now, the domain is actually the set of all inputs or first values of a function. The domain is the set of all inputs or what you may call the x values in a function. That is what we call the domain. Then the range is the set of all outputs, or what you may call the y values. That is the range. So in every ordered set or ordered system, you have the x value and you have also the y value. Now let's look at this little example. Now, the previous example we've been given are examples of disordered pairs, where we have to link one of the members of a particular set to other members of that same set, or we link members of one set to members of another set. So, but when we talk about ordered pairs, the linking has already been done. So we are having x values and we're having y values already. So let's look at example. Now, for ordered pairs, now let's assume we have something like this. We have 1 and 2, and then we have -3 and 4, and then we have 5 and 6. Now this is already an arranged pair, so we call it ordered pair because it's already an arranged pair. It's not the type that you have to link one with another. in these values, we have, for every of the values in each bracket, we assign them x, y, x, y, x, y. So if for this kind of question we are asked to find our domain becomes 1 minus 3 and 5, because we pick out all the x values. So our domain becomes 1 minus 3 and 5. And if we are asked to look for the range of the values, we pick all y values. So our range becomes 2, 4, and 6. So that is what we mean when we talk about domain and range. And the concept of domain and range will be applied more when we begin functions. But for now, we are still looking at relations. Now, let's see an example under relations. Suppose we are given this y, and we are given 1, 2, 3, 4, 5, 6, 7, and 8. Now, the relationship between y and other members of the set is to be looked for. What equation shows the relationship between y and the chosen members of the set? We have y being linked to 3, y being linked to 5, and y being linked to 7. So suppose we are given options as regards what equation best suits or is used or can be used to describe this type of relation. And if we are given options and we say the first option is y equals to x plus 3, the second option is y equals to 3x plus 2, and the third option is y equals to 2x plus 3. Now, having been given these different options, we can simply choose which one will best be able, which equation best describes this relationship. That is the relationship between y and the chosen numbers in the set. Now, if we are going with A option, we say, okay, y here is 3, and we can assign any value for x from 0 to any value for x. So let's assume y is 3, and then x, we have x plus 3. Now, our interest is what value, if we continue to change our values from x, for x from 1 to, let's assume 10. We use 1 first, we use 2, we use 3. We want to be sure that when we are making use of the values, we are able to get the values of y. We're able to get the values of what? Y. So if we use 1 as x, let's assume we don't know our y. Let's assume we don't know our y. And we just have x plus 3 as we are going with our first option. Now, we use x as 1 plus 3. It means the value of our y will be what? 4. The value of our y will be 4 if we're using x as 1. And if we look at the relationship between y and these 3 members of the set, we'll see that 4 was not chosen to show any, there's no relationship between y and 4. So it means that A is not the correct option. Now, if we try B, and let's assume we make x 1, and our B option tells us that 3x plus 2. Now, x, if we make x 1, we'll have 3 multiply 1 plus 2. And 3 multiply 1 plus 2 will give us what? 5. So we can see that we already have one of the members that is related, that y is related to. Now, if we make x2, we have 3 plus 2. Now, this will be 3 times 2, which is what? 6, plus 2, which is what? 8. Now, it does not still satisfy what we have here. It still doesn't satisfy what we have here because the numbers we are looking to get is 3, 5, and 7. So, we won't go with our option B. Now, let's go for our last option, which is what? 2x plus 3. Now, if we go with our last option, which is 2x plus 3, if we put x as 1, we'll have 2 multiply 1 plus 3, and that will give us what? 5. If we, okay, let's begin with 0 first. If we put x as 0, we have 2 multiply 0, which is 0, and then plus 3. And that will give us what? 3. We've gotten the first. If we put x as 1 plus 3, this gives us what? 5. We've gotten the second. And if we put x as 2 plus 3, we've gotten the third. So the equation that best explains or describes the relationship between y and these 3 members of this set is 2x plus 3 equals y. So having looked at this, we now look at the different types of relations. The different types of relations. Types of relations. So we have about 7 different types of relations which we are going to look at. And we'll begin with the first, which is known as the empty or void relation. Empty or void relation. Empty or void relation. And now, an empty or void relation is one in which there is no relation between the 2 sets. So if you are given 2 sets, there is no relationship between them. We say it's an empty or void relation. For example, if set A is given as 1, 2, and 3, then an example of a void relation would be using arrow. We use our arrow to signify relation. Would be using x, y, such that x minus y is equal to what? 8. Remember, I said that an empty or void relation is whereby the members of one relation or one set is unrelated to the members of another set, or all the members in a particular set are unrelated. Now, if for instance we have set A, which is 1, 2, and 3, and our relation we're using x and y, where x minus y is giving us 8, to prove that these 2 sets are unrelated. Now let's assume that because we are having x and y, we can assign out of 1, 2, and 3, we can use about 3 different means or ways to assign x value and y value. We can say our x and y can be 1 and 2, our x and y can be 2 and 3, and our x and y can be 1 and 3. So now if we consider this x minus y equals 8, we'll see that 1 minus 2, if we are going with the first choice, 1 minus 2 cannot give us 8. We'll also see that 2 minus 3 cannot give us 8. And we'll see that 1 minus 3 also cannot give us 8. So what it means is that these 2 sets are unrelated. So we call this a void or empty set, empty relation. So let's look at the second type of relation. The second type of relation, which we call the universal relation. The universal relation. So, in universal relation, every members of the set is always related to members of another set. They are all related to each other. So if, for instance, we have set A being A, B, and C, now an example of a universal relation would be taking our arrow as X and Y, where X minus Y will be greater than or equal to 0. Now, in this case, we don't know what A is, or B is, or C is, and we also don't know, we can make X and Y either A, B, B, C, or A, C. So whatever value we are assigning to A or B, we end up having a value that is either greater than or equal to 0. Either greater than or equal to 0. For instance, if we say our A to be 3 and our B to be 2, so using A minus 2, we are having something greater than what? 0. So whatever we are assigning to A and B and C, when utilized, must be able to give us a value that is greater than or equal to what? 0. And that is just it. So this is what we mean by universal relation. Then we look at the third type of relation. The third type of relation, and this is what we call the identity relation. Identity relation. The identity relation. Now, in identity relation, every element of a set is related to itself only. Every element of a set is related to itself only. So, for example, we have our set A. If it's A, B, and C, the identity relation that is represented by I will be A and A. Remember, we said the identity relation is whereby every member of the set is related to itself. So identity, we are saying A is related to A. We are also saying that B is related to B, and then C is related to C. So this is what we mean by identity relation. So in summary, we can say that our identity relation is A related to A, where A is a member of set A. Now, we mustn't forget that this symbol in mathematics is actually member. So we say that the identity where A is related to A and where A is a member of set A. So this is the third type of relation, identity relation. So where every member of a set is related to itself. We go to the fourth type of relation. We move to the fourth type of relation, and which is the inverse relation. The inverse relation. Which is the inverse relation. Now, inverse relation is when the set has elements which are inverse pairs of another set. So, whatever a particular set is, or whatever the members of a particular set are, the inverse relationship is, for instance, if we say A is related to B, the inverse relationship will be B being related to A. So let's assume we have a set A and we're having A and B, and then we have C and D. In set A, we are looking at the fact that A is related to B and C is related to D. Now, if we are taking the inverse of A, let's represent it by r to power minus 1. That's 1 over r. That's the inverse of the relationship of the members of set A. So if we are representing our inverse with r raised to power minus 1, and what we are saying is that the sets, that the members that will be found in this will then be B related to A and D related to C. So this is what we mean when we speak of inverse relationship or inverse relation. So in summary, we say that the inverse relation is A is B related to A, where actually A, that is in the previous set, A was actually related to B for members of R, of set R. So the inverse set will be having the opposite of the relationship. So this is what we mean by inverse relation. So we'll move over to the fifth type of relation. The fifth type of relation, which is reflexive relation. Now, in reflexive relation, every element maps to itself. If we have, we need to, when going through this, we need to consider the difference between these types of relations, because sometimes you may actually get confused. But if we can put in mind or bear in mind the characteristic of each type of relation, we'll be able to get it. So in reflexive relation, every member is actually being mapped or to itself. So if we have a set A and we have 1 and 2, a reflexive set or reflexive relation would be 1, 1, 2, 2, 1, 2, and 2, 1. Now this is like a mixture of both identity relation and inverse relation. So this is what we call reflexive relation. We're having 1 being related to 1, 2 being related to 2, 1 being related to 2, and 2 being related to 1. So every member of the set is related or mapped to itself. So we say that, in summary, A related to A is member of R, the relation. So this is what we call reflexive relation. And then now we look at the sixth type of relation, which is known as the symmetric relation. Which is known as the symmetric relation. So in symmetric relation, if we say that A is equal to B, and A being equal to B is true, then we can say that B is equal to A as well, which is also true. So what we are saying is that if we have BA, or for instance, if we have our arrow being 1, 2, and 2, 1. For a set A, it will be 1 and 2. So what we are simply trying to say is that if, for instance, we have this, what we are simply saying, if it's a symmetric relation, what it means is that 1 can be equal to 2 and 2 equal to 1, or A equal to B and B equal to A. So long as A equal to B is true and B equal to A is also true. So this is what we call symmetric relationship. So we can say that A is related to B and B is also related to A for all of A, B being members of set A. For all of A, B being members of set A. So we can assign 1 as A and we can assign 2 as B. So what we're simply saying is that if A is related to B, also it means that B is related to A for all the members A and B. For all of A, B being members of set A. So we now look at the last type of relation. Last type of relation. And that is the transitive relation. That's number 7, transitive relation. Now, if we say in transitive relation, if we say that X and Y are members of R, and also we say that Y and Z are also members of R. So what it means is that X and Z are also members of what? R. Now this is what we mean by transitive relation. So if we are saying X and Y member of R, Y and Z member of R, so what it means is that X and Z are also members of what? R. So in summary, we can say that X related to Y and Y and X related to Z will also give us, okay, that should be Y related to Z will also give us X related to what? Z. If we say what X is related to Y and Y is related to Z, that gives us the conclusion that X is related to Z for all of X, Y, Z being members of set A. So we are assuming this to be set A. So what it means is that X, Y, and Z are actually members of set A. So we've succeeded in seeing relations and the type of relations, and then we'll see you another time.